An AI coding assistant can produce a convincing change even when it's working from the wrong files, following the wrong rules, or recommending an unsafe dependency. So the real question isn't simply whether it can write code. The question is whether you controlled the conditions under which it wrote that code. When AI participates in implementation, responsibility doesn't disappear. Instead, that responsibility changes shape. The developer is still responsible for deciding what information enters the working context, which repository instructions actually apply to the task, and what must happen before a generated change is allowed to enter the codebase. That's stewardship. It's not about passively accepting an answer, and it's not about reducing the entire process to one clever prompt. It means actively designing the environment around generation. In this video, we're going to turn that idea into 3 practical gates: context, instructions, and dependency verification. Together, these gates give developers a repeatable way to review not only what an assistant produced, but also the conditions that shaped what it produced. Let's start with context. Open files help the model interpret a request, which means the files exposed to it aren't just neutral background. They're part of the request as the model encounters and understands it. Before asking for a change, identify the files that actually describe the problem. That may include the implementation being changed, the code that interacts with it directly, and the focused repository guidance that's relevant to that specific location. The important principle here is relevance. Expose the material the model genuinely needs in order to interpret the task. Then, inspect the working context from the model's point of view. Does it contain the files that explain the request? Is an important file missing? Are unrelated files still open, competing for attention, and potentially affecting the interpretation? Context control isn't merely preparation that happens around the task. It's part of the task itself. By deliberately exposing the relevant files, the developer creates clearer conditions for the assistant to understand what kind of change is actually being requested. It's tempting to treat context as a quantity problem. If some context helps, then surely more context must help even more. But the supplied findings point toward a different interpretation. Context stewardship is a relevance problem, not a volume problem. Unrelated files can affect the way a request is interpreted. A file from another feature, language, or framework may introduce patterns that simply don't belong to the current task. The issue isn't that broad context is automatically harmful. It's that every additional item becomes another possible influence on the model's interpretation. So, removing unrelated files is an active engineering decision. Ask what each exposed file contributes to the work. Does it define the behavior being changed? Does it provide structure that's directly applicable? Does it contain a rule that belongs to this path? If the answer is no, that file may be noise. The goal isn't to create the smallest possible context at any cost. It's to create the smallest context that still remains sufficient. Enough information to understand the change, but focused enough to avoid irrelevant signals. Files are only one part of the environment. Repository instructions also shape how an agent approaches a task, and those instructions need clear boundaries. Keep general repository instruction files focused. They should contain guidance that's genuinely broad enough to apply across the repository. Specialized rules, on the other hand, should be organized by path, so the agent encounters those rules in the places where they're actually relevant. That distinction matters when a repository contains different languages, frameworks, or areas with different conventions. If every specialized rule is presented as though it were a universal rule, the agent can apply guidance in places where it doesn't belong. A framework-specific instruction can end up influencing work outside that framework. A language-specific convention can appear relevant to a task that's written in another language entirely. Think of instruction design as a routing problem. General guidance travels everywhere. Specialized guidance travels only to the paths where it applies. The developer's job is to keep the global layer focused while making the specialized layers discoverable through the repository structure. Better boundaries reduce irrelevant guidance before generation even begins. Up to this point, stewardship may sound mostly like an output quality practice. Provide better context, route instructions more carefully, and improve the conditions for producing a relevant change. But the stakes change when an assistant suggests modifying dependencies. A dependency change isn't simply another generated line that should be accepted because it looks plausible. AI can suggest dependency changes, but every dependency it suggests must be verified independently. That word independently is the hinge. The assistant's own explanation doesn't count as verification of its recommendation. A confident description doesn't somehow create a separate check. The developer or the team has to validate the suggestion through a process that exists outside the generation itself. This is the point where stewardship becomes a security issue. The decision affects what may enter the project through its dependency graph. The right response is neither automatic trust nor automatic rejection. It's a controlled gate. Pause the merge path. Identify exactly what has been suggested and require independent verification before treating that dependency change as acceptable. Independent verification is one layer. Automated vulnerability auditing is another. Generated dependency changes should have to pass both layers before merge. These safeguards perform different roles. Independent verification asks whether the suggested dependency should be accepted in the first place. Automated vulnerability auditing checks the dependency change through a repeatable security control. One safeguard doesn't replace the other because they're answering different questions. That separation should be reflected directly in the workflow. If an AI-assisted change adds, removes, or updates a dependency, the review shouldn't stop at the generated diff or at the assistant's rationale. The dependency suggestion must be independently verified, and automated vulnerability auditing must run before the change is merged. Making the audit a merge condition turns the principle into an enforceable boundary. It's no longer an optional reminder that can be skipped because a particular change appears routine. The team retains control of integration by requiring the security check at the exact point where generated work would enter the codebase. Generation can propose a change. The merge process still gets to decide whether that change enters the project. Here's the full framework. Gate 1 is context. Expose the files that are relevant to the request, and remove unrelated files that could influence how the request is interpreted. Don't measure context by how much the model can see. Measure it by whether the visible material actually helps explain the task. Gate 2 is instruction scope. Keep general repository instructions focused. And then organize specialized language or framework guidance by path. The agent should receive the rules that apply to the location being changed, not every rule the repository happens to contain. Gate 3 is dependency verification. Independently verify every dependency suggested by AI and require automated vulnerability auditing before a generated dependency change can be merged. Preserve both layers because independent verification and automated auditing perform different jobs. Together, these gates make stewardship concrete. You design the conditions around generation, and then you retain human-controlled boundaries before integration. The assistant contributes to implementation, but the developer still controls what it sees, which rules reach it, and what must be verified before its work is allowed to enter the codebase. Before accepting your next AI-generated change, inspect more than the final diff. Take a close look at the environment that produced it. First, look at the files that were exposed. Were the relevant files present, and were the unrelated ones removed? Second, inspect the repository instructions that applied. Was the general guidance focused, and were specialized rules routed by path? Third, follow the dependency verification path. If the assistant suggested a dependency change, was that suggestion independently verified? And did automated vulnerability auditing run before merge? That gives you a simple 3-part stewardship test. Did the model see the right context? Did it receive only the applicable rules? Were its dependency suggestions independently verified and audited? The answer itself is only the visible output. Stewardship means examining the conditions that shaped that output, along with the gates that determine whether it can be integrated. Control those conditions, and AI-assisted development remains a process that the developer actively governs. If this framework helps you approach AI-assisted development more deliberately, subscribe to Neural Stack and share in the comments which of these 3 gates your current workflow makes the easiest or the hardest to inspect.